Okay, so hello everyone. For those of you who maybe weren't at the platform event over the weekend, I will introduce myself. My name is Cornelia Davis. I am a community engineer within the Cloud Foundry group. That's a relatively new gig for me. I came to Pivotal through EMC, where I worked at the corporate CTO office level. Been working with Cloud Foundry kind of part-time on the side for about a year and fell in love with it so much that recently made the big jump over to work in the Cloud Foundry group itself. I really want to be part of making this product insanely successful. And you want to introduce yourself real quick rather than disrupting in the middle?
Yep, that's fine. I'm Frederick, and I'm also a community engineer on the Cloud Foundry team. I've been doing this for about 9 months now. So like Cornelia, I have 1 foot in the engineering team, 1 foot out with customers, also deal a lot with partner integration into Cloud Foundry.
Okay, awesome. And so what we're going to talk about today is, you can see the titles around extending Cloud Foundry. So we're going to talk about a couple of different areas. I'm going to go to this slide as the first slide. Some of you may have seen this slide. But when we talk about Cloud Foundry, there's really kind of 2 camps that we need to talk about, 2 different groups of individuals that are doing things with Cloud Foundry. And I'll try to get a feel from you in just a moment on what camp you fall into. But let me explain what the camps are first. When it comes to Cloud Foundry, there are the individuals that are going to operate the cloud. Those are the individuals that are going to install Cloud Foundry, that are going to keep it up and running, that are going to make sure that there's enough capacity in the cloud for people to push apps into the cloud. And then there's another set of users who are the people who are going to be building apps and pushing those apps into the cloud. So there's really those 2 camps, and we refer to them on this slide as the operator of the cloud and the developer who's going to be using the cloud. So by a show of hands, how many people would consider themselves over in the operator camp? Okay, and how about the developer? Okay. Interesting. So, and I think that I saw that a lot of people raised their hand for both. And the reality is that Cloud Foundry is still a relatively new product, and we probably all fall into that category of being in both camps. We have to stand it up. We also know that we're going to be pushing apps to it. Ultimately, those roles will diverge. And I'm working with customers, for example, GE. If you were there yesterday for the panel, you saw that GE is deploying Cloud Foundry internally as an internal PaaS. Their customers are all the different units within GE, GE Power, GE Avionics, all of those types of guys. So ultimately, they are going to have developers that are just using the platform for development. But in the meantime, right now, as we're standing up that cloud and figuring out how those applications are going to be built and deployed and all of that stuff, we wear both hats. The reason that I brought this up is that we are going to talk today about 2 different places that you're going to do extensions, 2 different places that you're going to extend Cloud Foundry capabilities. One of them falls more in the operator camp, and that is extending Cloud Foundry with custom services. So how many people here have pushed an app, even if it's just a Hello World app? Outstanding, most of you. That's great. So you guys know about pushing an app. You know that what we call services are really kind of the persistence. They're generally the databases at the back end. That's one thing that we're going to talk about, and that's the part that I'm going to talk about, is how you build custom services. And I'm going to tell you about different ways that you can extend services in different scenarios, and I'm actually going to go into the details of the APIs. And then Scott is going to talk about the other side, which is the cool thing is if you are familiar, how many people were you doing Cloud Foundry with V1? Okay, so you recall staging. So when you staged an application, we provided support for a lot of different languages. And if you wanted to extend the list of languages that you wanted supported in your cloud, you had to go into this directory and modify this file, and you had to go into this directory and drop another thing over here, and you had to do this, and it was all operator side. All totally operator side. Now, with buildpacks, we're actually putting that control, that dizzying power in the hands of the developers themselves. And that's the part that Scott's going to talk about, is he's going to go into the details of buildpacks. So I'm going to go ahead and jump into services. And the first thing that I'm going to do is I'm going to start off with a demo. This is Spring 1, and so I'm going to try to do as much demo as possible, although I do have a ton of slides. Well, not a ton of slides. I only have about 16 slides that each have about 25 builds on them. But I promise they're all pictures. So we'll go from there. So let's see if I can get over to my demo. Where is my... Okay, I'm looking for my terminal window. And is it, oh, it's probably over there. There we go. All right, so this is not ideal, but I will do my best to crook my neck in this direction. The other thing that well, no, we won't worry about that. Okay, we'll go from here. And the first thing that I want to do is very simply push an app. If you guys will bear with me, I am going to go ahead and I can't do it. Yep, I'm going to mirror the displays. I was not mirroring them because it's easier in Keynote, but I'm going to do this. So Andy and others, if you guys can help keep me on time, that was one of the reasons I mirrored Keynote. Okay, this is good. Now I can see what I'm doing. Okay, so the first thing that I want to do is I'm going to push an app. So let me make sure, first of all, that I'm targeting the right cloud. And I want to target run.pivotal.io. Up, CF target. Cool beans, and let me make that a little bit bigger so it's not wrapping to start. Okay. And CF apps, we'll see what apps I have up running there. I want to make sure, yep, my hello. I've got a number of other things. I was at the Intel Developer Forum this morning helping push some apps up there. But what I want to do is push a new app in there, and I'm going to push a simple Ruby app. So I'm just going to do a CF push, but this time I'm going to do it with a trace turned on, because I want to show you something. So CF push with the trace flag, and that's the -t. And it's going to ask me for the name. I'm going to do hello. And notice that it's doing round trips. It's making REST calls. So if you haven't gotten this far to understanding what the CLI does with the cloud controller, is it's basically firing a bunch of REST requests. And everything that you do through the CLI goes to the cloud controller. Now it's asking me for the number of instances and some attributes about the size. Now it's asking me for a name. It goes and it does a REST request to make sure that that name isn't already taken. Asks for a domain. Now it's checking to see, the host is taken. So my mistake, I must have forgotten. Let's do hello to. It did that REST request and it found that there was already a hello. So I will pick hello to. And, oh, of course, that is, hello to is going to be taken as well. I'm at run.pivotal.io. Let's do hello. Cornelia, that one maybe won't be taken. Shouldn't be taken unless I've already pushed something. All right, we're good there. And now it's asking me, do you want to create any services for the application? So remember those HTTP requests. So this is the first time that we're touching services. So I'm going to say, yes, I want to create a service for the application. And it did an HTTP request there. That's what's up here. And I won't go through the details of it. I just wanted to show you that it went and it did an HTTP request to find out what services are available to bind to my application. So I'm going to go ahead and grab a Mongo, let's say. And I'll take the default name. And then it asks me which plan. I'm going to take the sandbox plan. And now it's going off and creating the service. And so you can see that it's creating the service. And if we scroll up a little bit, it did more than that. It actually bound the service as well. So you see how it's doing a post here for service bindings? It did 2 different HTTP requests. And I'm pointing that out now because I'll show you some pictures in just a moment that shows the entire flow of how that works. So we don't want to do any other services. I'm not going to bind any other services. We'll do some of that later, and I'm not going to save the configuration. And now it's going to push the app up in there, and I'll be able to bring that app up. So let me go ahead and find that. And help me remember, what did I call it? I called it Hello Cornelia, right? And let's see if it is done yet. Should be done in just a moment. And this Ruby app, by the way, is if you go into our GitHub repository under Cloud Foundry, you will find a repository that is called, so there you can see that the push was successful. You'll find a repository that's called something like test assets or something like that. We're all TDD, test-driven development at Pivotal Labs, which is where Cloud Foundry's developed. A whole ton of apps in there. So this is an app that I just took out of that sample apps area. So I'll show you what that fancy app does. It basically throws out a bunch of stuff onto the screen. It does provide an endpoint for services. So you can see here is the list of services that I've bound to my application. So you can see that the vendor is MongoLab, and here's the name of my instance. This is just what's showing, and I can show you the code, in fact. I think I've got the code here, so let me do a cat on, I think it's called app. No, let's see. env test, Ruby. So you can see here that under services, what it's doing is it's grabbing a value out of an environmental variable, vcap services, and that's where all the vcap services information is. That's all the information of the services that are bound to this particular application. And we'll look at that in more detail as we go through the presentation. And what we've done here is we're just pulling out two fields. So that vcap services environmental variable is a JSON payload that has a whole bunch of information in it. The service plan, so you saw the sandbox that I chose, all that information's in there. We've just pulled in our app code here out the vendor and the name and displayed that in the browser. So with that context, I wanted you to be able to see, and now I'm not happy with the screen resolution, but we'll make it. Now what I want to do is build number one. I want to step through that. I wanted you to see the context of those two separate calls with respect to services. So now when I do that push, remember that there were two. I talked about the two different HTTP requests. One to create the service. We call that provisioning of the service. It's an HTTP request that goes across. And then the second one we'll go through is the bind operation. At that point, the cloud controller sends an HTTP request over to the service broker for the service that you have selected. So it sends it to the service broker for Mongo Labs. And I'll show you exactly what happened on the Pivotal site, I'm sorry, on the run.pivotal.io site in just a moment. How many people here called them service gateways in the past? Please do not call them service gateways anymore. They are we're calling them service brokers because, and you'll see why at the end of the screen, so I'll come back to that, emphasizing that point. We call that the service broker. It fulfills the same purpose that a V1 service gateway did. We've just named it more appropriately. Okay, so now that service broker has to do the work to provision that service, to provision that Mongo Labs database. And you'll notice here that I've labeled that arrow up to you. Now, how many people built service gateways for V1? Nobody. I did. It wasn't easy. But what you did back then was you took a whole bunch of Ruby base classes and you subclassed those. And it did a whole bunch of stuff for you. And I'll show you what some of those internal things were. And kind of the API for services was the Ruby code. There really wasn't a crisply articulated, there was a crisply defined API, but we didn't really crisply articulate it, and you could kind of reverse engineer it out. What we're doing with version 2 and services, Cloud Foundry version 2 and services, is that we are crisply defining the API for the service broker. Everything behind the service broker is up to you. You can decide how you want to implement that service broker. You can decide whether you want to borrow some of our Ruby base and use those Ruby classes as base classes, or you can decide to program in something other than Ruby. Because we are giving you the API, it's an HTTP-based API, and that's all you need to do. And I'm going to go through that API in detail with you here today. So you're going to go ahead, and the service broker is going to do its work, and then it's going to respond back to the cloud controller HTTP request response. I'll come back to that in a moment as well. You'll notice that after it returned to the Cloud Controller wrote something into its little database there. So the Cloud Controller has its own record of everything that's going on in the cloud. So it wrote down what it got back from the service broker and stored it in its database. And now it responds to the CLI. The CLI, if you remember, then did a bind as well. So the bind comes across as an HTTP request. Same thing over here. You're going to do that. The Cloud Controller is going to send an HTTP request to your service broker implementation. Up to you what you're going to do on that bind. And again, I'll talk about that in more detail. And then it returns to the Cloud Controller. Oh, and it writes more things into the database. After the bind, one of the important things that it probably does is it probably writes credentials into that Cloud Controller database. Credentials for access to that service, okay? So after the bind comes back, then if you remember, there was a whole bunch of other stuff that happened, which was staging the application. So that's what this ... is. And then it goes ahead and it does the deploy and it does all of that staging, and you saw all of that stuff scrolling on the screen. At the time that it's doing the staging, and this is where Scott is going to talk a lot more about the staging and the build, that's where the build packs come in. What the outcome of that staging process, so there's a whole bunch of work that happens there, the staging, is that you get a droplet that's deployed into the DEA. Notice that that droplet has the credentials in it, okay? Where are those credentials? Remember that environmental variable that I showed you? That's where the credentials are. The credentials are made available to your application as environmental variables, and we access them from the code, okay? Now, when Scott talks about it, he'll talk about some other things that happen. You don't necessarily, in your application, have to look up that environmental variable. There is a little bit of magic, that's not really magic, looks like magic, that will make that job a little bit easier for you in certain instances. Now, here's why we don't call them gateways. When the browser then goes to access that application, which is running in the DEA, it goes straight from your application to the service. It's not a gateway. It is not in the control plane at the time that you're running the application. The broker is just there to broker connections as you're doing that deployment. Okay, does that make sense? Cool. All right. So the next thing that I was going to do, so that's what those notes are, and the broker's only used during provision and unprovision. The demo I was going to do here was I was going to pull you over and show you where that environmental variable was, but I've already done that, so I'll go ahead and charge forward. So I'm, 10, 15 minutes in, and now I'm going to tell you what my agenda is. That's kind of my MO. I always start off with something, and then I talk about what I'm going to talk about the rest of the time. When it comes to services, I want to explain to you 3 different things. I want to talk about service offerings that are available on run.pivotal.io, and I want to talk about the implementation there. The second thing I want to do is talk about building your own services. So, for example, my colleague Gary, who is from EMC, he's working in a group where they've created their own service for an EMC product called XDB, an XML database. They also built a custom service for Cassandra. Okay, so they've built custom services. So I'm going to talk about what that looks like now. And then finally, I'm going to talk about a third thing that we call user-provided service instances, and I'll explain what that is when we get there in the slides. Okay, so this is a really simple picture that shows what's going on. How many services is Pivotal? So this is a question, and it's not a trick question, but how many services is Pivotal providing on run.pivotal.io? Goose egg, not a 1. We don't have any services that we have built that are running on run.pivotal.io. And here's why. And those of you who have the legacy with version 1, we provided 5 different services, remember? Why did we get rid of those? Well, we're not really good at that. The first question that we got was always, oh, you've got these databases, so what do you do about replication? And we said, well, we don't do anything. Oh, what do you do about high availability? Nothing, sorry. And so there's all of these companies Yep. So there's all of these companies that are in the business of producing services, reliable services with those different service levels, with those plans, so that you can choose one that doesn't have replication. Maybe it's a free plan, or you can ask them to do the backup and recovery for you, or the replication, or the high availability. So we made the decision for run.pivotal.io to create a marketplace. And we have a marketplace of services. So when you do select a service, when I selected MongoDB, it was going to MongoLab. It wasn't happening in our cloud at all. It was happening externally. Yes?
Are we allowed questions?
Yes, absolutely.
Do you help with billing or metering?
I believe we do, yes.
All about billing. When we're running on Amazon and we connect to those services, what you get from us, or what you will get from us when we switch on billing, which is currently on because we're in the trial period, is a single bill for those services plus the Amazon usage. You won't see either the end service or the Amazon stuff, just get a bill from us.
Yep. Great. Thank you, Andy. Yes?
Why don't we use any of the Amazon services directly, like the Amazon database services?
That is probably a business question, and I am not prepared to answer that question. Now, we use Amazon services internally. So when you saw that Cloud Controller database, we're using internal services. I'm not sure actually for the Cloud Controller database whether we are. Yes, RDS. We're using RDS for that. Yep. But that's a business question. I'm sure it's a partnership thing, and I'm not prepared to answer that question. I'm a propeller head, so. Okay. So the way that we do that is we did not write all the brokering to each one of those services. We engaged with AppDirect. AppDirect, they're in the business of brokering to all of those different third parties on the outside. So let me just show you. Oh, and if you are a partner, if you come from one of these companies that can provide a service like this into our marketplace, this is the person that you need to contact. You need to contact Nima. He's our business development guy. And he's the one you can talk to about, hey, I've got this really nifty service that I want to make sure is in the marketplace on run.pivotal.io. Now, let me show you just very briefly what happens on the inside. You saw that picture, so you're going to see that picture over and over again. Got the Cloud Controller. We have a broker. We did build that broker together with AppDirect. So when we do a push, what's happening there is that there's all that logic in the AppDirect service broker that communicates with the AppDirect application or service, and that communicates with these third parties, apparently including billing information, metering information, all of that stuff is happening there as well. One of the things that you'll notice here is on the next click, you'll notice how does the browser access those services? Accesses the services directly. It may, I don't think it actually goes, it doesn't go through AppDirect there either. I am not sure of that, but it definitely doesn't go through the broker. Okay, so you're going to see this theme over and over and over again, that once the droplet is staged, it's accessing the services directly. It's not going through any internal Cloud Foundry things anymore. All right, so let me show that to you, and let me, in fact, see where I am on time. Is that already 5 minutes till 5? Okay, so I'm going to skip that demo because the real good stuff is coming up. What I was going to show you was I was going to go into the console. I was going to create one of those apps, but you already saw my MongoDB where I created that question. I am sort of around, and I'll answer that question at the end, but that's a really good question. I'm around this evening for sure, so I'm happy to show you more demos. But there's a better demo that I want to show you at the end that's a little bit more interesting. So Cloud Foundry, so that now I'm on to number 2, you building your own Cloud Foundry services. So I said there's 0 on run.pivotal.io. When you take a look at what we're doing in the open source repositories, we now have 1. We decided after yanking the 5 that we really did need to understand everything about building one service, one really high quality service with failover, with data replication, that we needed to understand that ourselves to be able to provide the right infrastructure around it. And that is the MySQL service. So we are building out a service broker, and we're building out a service capability for MySQL. And so I'll point you to that repository there. It's in Cloud Foundry CF Services Release. That's where you'll find MySQL. Now, you could count, depending on how you count, there might be many, many more. But we've pushed those into a different repository now. They're in the CF Services Contrib release. And there you'll find not only the 5 that we built before, but a whole bunch of others that had been built before. And so those are ones that have been contributed by the community. A lot of those have been kind of shimmied from V1 to V2, so they're not necessarily fully up to the V2 standards, but it's also a good resource to take a look at the code. So how we build them, I already mentioned that we used to subclass a bunch of Ruby base classes, and now it's in V2, it's a RESTful protocol. And that protocol's evolving, and I'll tell you where some of those evolution points are. The good news is that it's evolving to make it even easier for you. So if you're writing to our current RESTful interface, which is what I'm going to show you today, the good news is that in 2 or 3 months, when we come up with the next version, you're just going to get to throw away some of the code that you wrote now. It's going to get easier. We're taking on responsibility for some of what you have to do right now. And I'll go over that in a little bit more detail. There's 3 parts to the protocol, and I'm going to go over each one of those. The first thing is, number 1, first part of that protocol, is that the broker, when a broker comes online, okay, and Cloud Foundry is built so that the components can come up and down, and you don't have to bring all of Cloud Foundry up or down if you want to add a component. Let's say I want to add a new service broker in, and I deploy that into my Cloud Foundry. When the service broker comes in, the service broker has to let the cloud controller know, here's what I'm offering. So this is the first part of the protocol that you need to build. So you'll notice it's very faint, but there's a light yellow around the service broker. Everything that you're building is what you're building in the service broker. In some cases, you're building a REST client. And in some cases, you're building a REST service. And I'm hopefully going to make that really clear to you here on the stage today. So service broker has to tell the cloud controller what its offerings are. In order to do that, it has to authenticate to the cloud controller. So the first thing that you need to do is you need to have an account that authenticates to the UAA. Okay? So that's the first thing that you're going to do in your code. And you're going to get back a token. Then you're going to issue an HTTP request to the cloud controller with that token. Okay? I'm sorry, and the HTTP request is in fact a query for what the current catalog is. It's my responsibility as a broker to say, oh, because maybe that broker came online because it was down, and it just came back online, and maybe there's already an offering in the catalog. So it's up to the service broker to get that catalog and say, oh, I've got something new, I need to offer this back. So it goes ahead and it gets that service catalog in an HTTP request with that token, and then it's going to issue HTTP requests to update the catalog. And the HTTP requests are things like post for new, put for update, and delete for get rid of it. Okay? All right, that's the first part. So you have to implement that as a part of your custom service. The second thing that you're going to do is you're going to implement that RESTful service that's going to support the bind and unbind. Remember the bind and unbind that came from the cloud controller to the service broker? You need to implement those endpoints, okay? So, but before you implement those endpoints, the cloud controller is going to be sending an HTTP request to the service broker. That needs to be secured. So how does that security work? Well, there's a shared secret over here in the service broker, and I'll talk a little bit about how we can orchestrate this a little bit better in just a moment. But there's a shared secret, and it's up to the cloud controller when it makes requests to deliver that shared secret to the service broker. So you need to, as an operator, remember you're the operator, as an operator, you need to provide that shared secret to the cloud controller. This is kind of out of band. It's not part of the provisioning process. It's out of band. It's going to get better, and I'll talk about that when I talk about Bosch in just a little bit. And so you make an HTTP request. There's support in the CLI for this. So there's a CLI that allows you to supply the shared secret to the cloud controller for your particular service broker. So that's the prerequisite. But then when the provision and the bind requests come, that's what's happening here. So the CLI asks for a service, so a provision or an unprovision. Up to you what you do with it. Up to you. Are you going to create a new database instance, spawn off a new process? Are you going to take an existing process and create a new database within it? Are you going to provision a new user? Entirely up to you what you do with that. And then, of course, it's going to respond. Same thing on unbind or unbind. It's up to you what you do there, and it's going to respond. So the key here is you are implementing the HTTP endpoints that are on the left-hand side of the service broker and doing whatever business logic you need at the back end. Okay? Now, what's going to come up next on my screen? How do I access it from the broker? Doesn't go from the browser. Doesn't go through the broker. Goes straight there. So the droplet gets those credentials and accesses the service directly. All right. Finally, the third thing that you need to implement in your protocol is what we call orphan management. And basically this says, hey, if the cloud controller always knows what the environment's supposed to look like, and if for some reason a service broker, a rogue service broker is out there, and it's not supposed to be anymore, it's not showing up in the catalog, but it's still out there, imagine what would happen. Remember, when it comes up, it's going to go and ask the service broker the cloud controller for the catalog and do all of that stuff. So you could end up with it bringing itself up again, and there could be all sorts of confusion. So there has to be an orphan management process. And so in this particular case, you need to implement inside of your service broker the cleanup, the eventual consistency. So I talked a little bit about this at the beginning with the service broker coming online. But it's the same thing here. If the service broker comes online but it's not supposed to anymore, the first thing your service broker is going to do, of course, is authenticate to UAA. That's the same as before. This isn't necessarily a separate piece of code in your broker. It's just a separate thing that you need to think about implementing. You're going to make that request to the cloud controller to get the catalog, and then you're going to need to clean yourself up. Okay, so there you might, in fact, want to clean things up in the database at the back end as well. Okay? All right. So that is the current API. That's what you need to implement if you're doing services today. Now, just to be confusing, that's kind of Cloud Controller v2 services, v1 of services in Cloud Controller v2, or in Cloud Foundry v2. There is a new version, we might call it v3. Hopefully we'll in some way make it clear. But the evolution on this API that I just showed you is that, if you remember, I said sometimes it's a client, sometimes it's a server. The next evolution, it's only going to be unidirectional. You are not going to have to act as a REST client and make calls to the cloud controller. All of that goes away. The cloud controller is taking on that burden itself. So all you need to do is implement that bind and unbind and the provision and the unprovision. You don't need to worry about that UAA authentication anymore. You don't need to worry about doing the orphan management. All of that stuff is going to be taken care of by the cloud controller. Yes. It's Mike, right? Yes. No. That is really, really, really good. And so going on the bottom there, but in order to be able to keep things eventually consistent, the cloud controller is taking care of that now, but we need to be able to allow the cloud controller to find out now from your service broker what's going on with the service broker. So you have to replace all of that stuff that you were doing in the direction from the broker to the cloud controller. You need to replace that with one more endpoint that basically says, here's what I got, so that the cloud controller can do all of the reconciliation. Okay? And then you can remove the orphan management. Question?
Will that also handle downtime of the service broker? So if the user wants to provision a service, but you know the broker's offline, they won't even say that that's available?
I don't know. I'll take that offline and I can try to get you an answer. Absolutely. There's another cool thing that's happening is I'm surprised that nobody said HTTP request response. We're in the world of distributed computing here. We do things asynchronously. Those are blocking. And we are moving toward an asynchronous provisioning model. So you will be able to, we're wiring it in there. I'm currently working with a customer who's saying, gosh, I really need this now. And our only solution is, well, make the timeout really, really, really long. But we are working on the asynchronous nature of it. So there will be a way for you to basically fire off and say, hey, provision this thing and let me know when you're done so that I can keep going on. Okay, so we are going to be adding some asynchronous stuff.
I have a question.
Uh-huh.
Could you talk about what is it actually happening when you bind a service? Like logically what's happening?
So logically what's happening is it's just doing those HTTP requests. It's entirely up to you what you want to do behind your service broker.
So in case of MySQL, what's happening?
In the case of MySQL, I'm going to get to that.
Okay.
And I'm going to try to go through these very quickly because I'm very close to eating into Scott's time here. So I wanted to give you a little bit of insight. So I did not pay him for this question, but the next 3 slides are all about some suggestions on what you might want to do in that it's up to you part. Now in version 1 of Cloud Foundry, we built all of our services with this pattern. You had what we were calling a gateway. It's labeled here a broker. When the request came to the broker, what we did, and there was usually only a single broker there, what we did was the broker fired off a message and dropped it on our internal message bus. That message, and notice, by the way, that all of the service instances are already started. So the MySQL processes were already started. And when one of those nodes, and the nodes are where all of the database instances are running, one of those would pick up that request, and it would go ahead and create a new database inside of the already running database. So the database was already running, but it did a SQL query to create a new database or a new database table inside of that. It responded back with those credentials and eventually went out. Okay? And the way that we started up all those processes, well, that was part of BOSH. And I won't talk about BOSH except for just a moment. Now, we're moving, this is to answer your question of what's happening with MySQL. MySQL is moving in this direction. Same sort of pattern here. The provisioner request comes in, we fire off something to NATS. One of the nodes picks it up, and what it does now is it is going to create a new MySQL process inside of a Warden container. So Warden containers are not just for app isolation on the DEA. You can use Warden containers for service isolation on your service nodes as well. And this is the pattern that we're following in the MySQL. So when somebody asks for a new database, we provision a new Warden container, put all the MySQL bits inside of that Warden container and start a MySQL process. On the bind, we create a new database instance with new user credentials and send those back. Okay? And so then we do the respond. And then another pattern that you might want to do, and I mentioned that Gary and his team had done some Cassandra work, is check out this pattern. We fire off a message to NATS, and now what we want to do is stand up a cluster. So a bunch of nodes pick up that message that's on NATS. These are just suggestions, okay? You can do them. This isn't the way that we implemented the Cassandra stuff, but you could do this. And now each one of those nodes is responsible for starting up individual nodes that are all forming a cluster. So that's another option that you could do. Okay, and then it responds and goes back. I'm not going to go through the BOSH stuff in detail because I'm out of time, but notice at the bottom the little comment that says you could use BOSH to configure in that shared secret thing. And oh, by the way, if you remember the unidirectional thing, that whole shared secret business is going away. Okay, finally, onto the third type of service. What about, so I've got my run.pivotal.io, my marketplace there. I've got my service broker stuff that I'm building on the other side. What about these guys in the middle? They're services that are, they're databases, for example, that are already stood up in your enterprise. My ERP system, my Oracle system, I don't want to bring those into Cloud Foundry, but I want my apps to be able to access those. What do I do with those? And that's what we're now calling user-provided service instances. And here's the way it works. When the CLI comes in, it makes so when you want to make one of these services available to the user, available to your Cloud Foundry users, you make a CLI request that basically puts the metadata in. Remember those credentials that are shown there? You put the credentials into the Cloud Controller database yourself. And that's it. That's all you do. You put those credentials in there. Now, when somebody does a bind or an unbind, they're not doing a provision or unprovision, only bind or unbind are supported here. You do a bind or unbind, you're going to access those credentials, and those become part of the droplet that's deployed, so that when your browser accesses it, goes to the droplet and connects to the databases here. Okay? I have a live demo where I can show you actually doing this. I'm not going to do it now because I am completely out of time. And this is what I told you. So that's it on services. I don't want to take any more time, so let's hold any other questions that you have on services for the end. I'll stick around as long as you guys want, and I'll show you demos if you want at the end of the session, but I want to hand it over to Scott now. Okay?
Thank
Sorry,
you.
Scott. Please forgive me.
Oh, you're right on time.
Okay.
According to my clock. In fact, I think you gave me an extra 3 minutes.
Oh, excellent.
So that'll give us plenty
So
of
should
time.
I do the demo?
Yeah.
Oh,
You want to do the
okay.
demo?
I
Go
didn't
for it.
realize I only had that I still had 3 minutes.
Go for it.
I'll do the demo then. Okay, let me come back over here and go into a different window. And I'm going to change my target over to a local instance that I have running. Okay, so here's my local instance that I have running, care of the cf-gs installer. And that's because I have a service that I have deployed on this machine. So I have a Cloud Foundry instance running. I also have a Gemfire instance running. So who's familiar with Gemfire? Okay, it's great, super. In-memory database, clustered, so that last picture that I showed you, lots and lots of nodes out there. Of course, I'm running all of the nodes on my one machine, but that doesn't matter in this particular case. So I'm running, and that's running externally, so that is not a service that's in Cloud Foundry. So what I need to do, if you remember, is that I need to provide those credentials in. So I'm going to do a cf create service. So this is where I'm providing that metadata, those credentials, and they're going to be written into the Cloud Controller database. So I'm going to do a cf create service, and I think, if I remember correctly, yep, no other arguments at this point. It's a user-provided service, okay, user-provided service instance, and I'm going to call it Gemfire. Okay, now it's asking me, okay, what metadata are you going to need to provide? It doesn't assume, these are just suggestions, e.g., host name, port, password. And I am going to make sure that I don't completely screw up. I'm going to look at my code to see, because I did this earlier and I used the wrong field name. It is called, where is it? Notice that I'm going down into my VCAP services here. Locator IP and port. Okay, a locator is something in Gemfire. So locator, IP, and port. And then I need to provide the values for those. So it's asking me first for schema and then for values. So 172.116.192, that's the local IP address here, and I happen to know, actually I'm running it in a separate VM. And that VM IP address is 131. The port for the locator is 55221. And I hit return, and it failed. Oh, because I forgot to delete one. So I already did this earlier, and I forgot to clear it. So it's complaining that Gemfire already exists. So this is the output, but it actually exists with the wrong thing. So I'm going to give it a different name. User provided. I'll do GF this time, and locator IP and port again. And the IP address. Sometimes I think I do type faster than I can cut and paste. 55221. This time it should work. GF, great. And now when I do a push of an app, and you can see here that I have a Gemfire client app, and I do a CF push, it's going to ask me for the name of that, so I'll call it Gemfire client. going to have one instance. The default memory is fine. I'm going to use that as the name. That's my domain. Now the important thing is, do I want to create services for this application? Yes or no? No. I'm only binding an existing one. Next question is, do you want to bind other ones? The answer is yes. And there is the Gemfire one, which was the original old one where I used the wrong schema. I select 2, bind another service, no, save the configuration, and that's it deploying. And I could show you the app, and you would know very clearly that Pivotal does not pay me to be a web developer. It's really horribly ugly, so I will spare you those details. If you don't believe me and you want to see it running afterward, please come out afterward. Now I'm 2 minutes over. So.
Well, that's a good strategy because I got called out for being a bad web designer earlier today. Didn't I, Andy?
Thanks.
Oh. Let's get Keynote back up.
I'll be your timer now.
Okay, thanks everybody for sticking it in today. I think most of you have been in this room all day long, which is a good thing. I was kind of counting on that because I didn't want to give too much Cloud Foundry overview in my part of the presentation. So we're going to use a lot of terminology that you've heard a lot of times already today. The goal of this part of the talk is just to take it a level deeper and get deeper into how DEA staging works and what build packs do exactly. So to start with, we're going to spend a few minutes on this slide just to talk about what happens when you do this CF push that you've seen probably 50 times already today. The CF command line or any other tool that you're using to push applications to Cloud Foundry, they all do the same thing. We have a Java wrapper library that you can write your own Java code to push apps to Cloud Foundry. It would do exactly the same thing. There's actually 3 steps that happen when you say I want to push an app. The first thing we do is create a bunch of metadata for the app. The name, the number of instances, the amount of memory, any environment variables you want to add to the app, the names of all the services you want to bind. All that is just a data structure that gets pushed up to Cloud Controller, and then Cloud Controller stores all of that in its database. And then the second step is to actually take the application files and upload those into Cloud Controller. Cloud Controller then takes those files and stores them into the blob store just as a raw set of application bits. And then we get to this step number 6 of start the application, and that next arrow says stage the app, and that arrow looks like it's the same size as all the rest of them, but that's where all the action is, in that line that says stage the app. And the rest of this talk is going to be going into basically what happens on line 7 there. But the DEA staging process kicks in, and once that DEA staging process is done, which is what we're going to talk about, then it takes this thing called a droplet and stores that into the blob store. And then every other instance of that application that started is just taking that droplet out of the blob store, dropping it into a new Warden container, and starting it up. So now we'll get into everything that happens in that number 7, stage the app arrow. So this term droplet you've heard many, many times today. Let's define that a little bit more clearly now. When an application gets started staging, the first thing DEA does is create a Warden container. That Warden container has an operating system sitting in it, and that's it. It's just a bare operating system. It does have Ruby on it, and we'll talk about why that's important in a minute. But it's got no Java runtime environment. It's got no Python interpreter. It's got none of that kind of stuff that your app might need. It's just a bare operating system. And then it puts the application bits onto that Warden container. Then it's up to a build pack to decide what else needs to be in that Warden container for an application to run. If it's a Java app you're pushing, you need a JDK or a JRE. If it's a Ruby app you're pushing, you need a Ruby interpreter. If it's a JavaScript app you're pushing, you need a Node.js runtime. Python needs a Python interpreter. That's what we mean by runtime in this case, is whatever it takes to actually run your application. You may also need a container. If you're pushing a WAR file, you need a servlet container like Tomcat. If you're pushing an OSGI bundle, you're going to need an OSGI container. So not everything needs a container, but most of the types of apps that you push are going to need some container to run in. And then you have libraries that may be a part of your application as well. If you're pushing a Java WAR file, then you know that the WAR file that you push already has all the jars that you need already bundled up into that. So in the case of Java, the build pack doesn't typically need to add libraries to the droplet. But if you're doing Ruby, the way it works in Ruby is you have a file that describes all of your libraries you depend on, so it's the build pack's responsibility to go fetch those from Ruby gems and put them on there. Node has a Node packaging manager where it describes the dependencies for a Node app. the build pack can also go get those node dependencies out of Node Package Manager's repository and pull them down. So all of that is happening inside of this Warden container. The build pack downloads and adds all these files to the Warden container, and once that's all done, the DEA takes this directory that all that was put in and bundles that up and calls that a droplet and stores it away. Every other time the application is started, it's taking that droplet, creating a brand new Warden container, putting all that back in the container, and then starting it up. This build pack concept, we knew that we needed a way to provide extensibility of how apps are run, and we started looking around to see what was already out there, and Heroku had invented this concept of build packs, and it works really, really nicely. So there's really no reason for us to go off and invent something else. So we took this design that Heroku had done and adopted it inside of Cloud Foundry. So we say that Cloud Foundry and Heroku build packs are compatible. It is possible to take a build pack that was built for Heroku and run it on Cloud Foundry. It's also possible for people to write build packs on Heroku that don't work on Cloud Foundry. So if you're writing a build pack and you want it to be compatible with different platforms as a service, you need to make sure that you're doing things that aren't real crazy in there, and that you're testing it on all those, because you can do things that make them incompatible, but it isn't very hard to make them compatible as well. So Cloud Foundry and Heroku both share this build pack design now. We think that's going to be an emerging convention that other PaaS providers will also adopt, because it is just so flexible and it's very easy to use. So also in Cloud Foundry, there's this concept of built-in build packs or bringing your own build pack. So if you just do the CF push without providing any other options, there's going to be a set of build packs that Cloud Foundry knows about, and it's going to test your application bits about each of those build packs that it knows about. And if one of them says, yes, I know what this application is, then that build pack gets to take over and do the rest of the work. If no build packs say, I know what this application is, then you get an error from the CF push that says, we don't know what you're trying to do here with this application. Then you have this ability to specify a build pack URL when you push an application where you're telling Cloud Foundry, I want you to use this build pack. It has to be a get URL, and then what the DEA does is it goes and clones that build pack into the DEA and then launches it. All of the build packs that we've seen so far are all on GitHub, but that's not a Cloud Foundry requirement. It just needs to be a get URL. They could be on Bitbucket, they could be in Google Code, they could be anywhere that hosts a Git repository. If you're running a public cloud, like Pivotal's hosted CF, then those bits need to be up on some publicly hosted GitHub repository. If you're deploying Cloud Foundry internally in your own enterprise, you could write build packs and storing them in an internal Git repository, just as long as it's visible to the network that DEA is running on. What does it mean for a build pack to be built into Cloud Foundry? It really doesn't mean very much. If you look on GitHub at the DEA source code, you'll see this directory here called buildpacks/vendor, and you'll see that there's 3 things in that directory called Java, Node.js, and Ruby. Those are Git submodules, which if you're not familiar with Git, it's basically Git's implementation of symbolic links. So each of these directories in buildpacks vendor is a symbolic link to another GitHub repository somewhere. So you can see where these 3 link to. In the case of Java, we have a repository called Java Build Pack that is a from-scratch build pack just for Cloud Foundry. And then the Node.js and the Ruby build packs are forks of Heroku build packs. So if you're deploying your own Cloud Foundry and you want other build packs to be built in, all you would do is fork the DEA repository, add additional submodules, delete these if that's what you want to do, and that's what decides which build packs are built in. This is the state of the world today for build packs. There are some efforts underway right now to enhance this some more so that you could have a concept of uploading a build pack into a running Cloud Foundry instance as an additional mechanism to adding more symbolic links to this directory. You would be able to provide a Git URL and say, I want this now to be a built-in build pack in this Cloud Foundry environment. You can't do that today, but probably in a couple of months we'll have something like that that you'll be able to do. That's not actually being driven by Pivotal, that's being driven by other people in the community like IBM that have a strong interest in doing that. So I think this is going to be a real good example of some community-driven features that end up in Cloud Foundry. So aside from those 3 built-in build packs that are in the open source code, there are a number of them that people have either built from scratch or tested on Cloud Foundry. And this URL that you see at the top is a little wiki page on GitHub that's just a community-driven list of things people have tested and that they know work. These aren't tested by Pivotal necessarily. We don't guarantee that these work. We don't have any automated tests that make sure they continue to work, so it is possible for these to be broken. This Python build pack is one that people had used the default Heroku one on Cloud Foundry and it worked fine, so it got added to this list, and then somebody changed that Heroku Python build pack and it broke. So that sort of thing can't happen with these, but we do have this community-driven list of things that people have tested and that we have somebody saying that it worked at one point. Since I made this slide, on Sunday, IBM announced their WebSphere Liberty Profile build pack that would be in this left-hand column as well as yet another community-contributed build pack that you can use. Excuse me. So what does a build pack actually look like? There is a very, very small footprint API for a build pack, and it consists of 3 scripts. These scripts can be written in either Bash Shell or more commonly in Ruby. If you looked at some of those build packs on the last slide, some of those would be written in pure Bash Shell script, and they tend to be pretty small. Any build pack that's more elaborate tends to bring in Ruby code because it ends up making the code much smaller and much easier to maintain. So each of these 3 scripts, when they get called at the right time, they will be passed this application directory, which is the place where the DEA has downloaded the bits for your application into this Warden container. So anything else you want to do inside the Warden container, that's the directory that you would do those things in. The compile script, in addition, gets a cache directory, which we'll talk about what that actually is. It's just a way for you to save some download time. So we're now going to go into each one of these scripts in detail and tell you exactly what they do, if my voice holds up. Thank you. So the bin detect script, its job is to look at the application bits and decide if it knows what this application is. So examples are, these aren't necessarily exactly the code that's in each of these build packs. These are just examples of the sorts of things that a build pack can do. So for a Ruby application, it may just look and see if there's a gem file as a part of the bundled bits. For a Node.js app, you need a package.json file so that you can see what the dependencies of the application are. So a build pack can see if there's a package.json file, then it's got to be a Node app. It really couldn't be anything else. I don't have Java on this list because we're going to go into a lot more detail on exactly what is detected in a Java application. Thank you. So what this script needs to do to match this API is if it detects the right files in there and says that it knows how to handle this application, it should return an exit code 0. It should also write to standard out a string that is really completely arbitrary that somehow describes what that build pack is. So for the Ruby build pack, it merely writes out the word Ruby. For Node, I believe it does the same thing. For the Java build pack, it writes out a lot more information that you could look at and use. But it's really, at this point, only serves to be human readable. It doesn't really give you enough information for most build packs to be able to do anything with it programmatically. So you return exit code 0 from your detect script if you know how to handle the application. If you don't, you return exit code 1. So what the DEA does, but this is back to built-in build packs versus pushing your own build pack. What the DEA does is it iterates over the list of the build packs it knows about and calls these detect scripts one by one until one of them returns an exit code 0. The first one to return an exit code 0 wins, and it's now the build pack that's in effect for this application. Right now, if you push with the build pack option, DEA doesn't bother calling that detect script because you've told it, I want to use this build pack. That could change in the future because there are some cases where it would be nice to get that string back that bin detect will write out and be able to see what happened there. So that may change in the future, that DEA may decide to call the bin detect, but today it does not. So compile is where all the action is. And compile is actually a little bit of a misnomer on Cloud Foundry. It's gotten this name from Heroku because when you push even a Java app to Heroku, Heroku actually gets the source code and compiles the Java code into class files. Cloud Foundry doesn't do that, so the name compile is a little bit of a misnomer. It's really more of a packaging process on Cloud Foundry. But the bin compile script is responsible for downloading any necessary things that the application needs to run. So in the case of Java, you're downloading the JRE. In the case of Ruby, you're downloading the interpreter. It's also responsible for downloading a container, so Tomcat, if that's what your build pack is trying to support, an OSGI container. And this is where a Ruby build pack would look at the gem file and run bundler to pull in any dependencies. A Node build pack would look at package.json and pull anything down from a repository. So compile is really where all the action is. The compile script may also do some transformations on the application bits if it needs to. In the case of a Java build pack with Tomcat, those application bits need to be in a Tomcat directory, in Tomcat web apps directory. So our Java build pack actually just symlinks the build files, the app files into that directory, but it could choose to move them, copy them, do anything else it might need to do to the application bits. And we saw on the slide earlier that compile script is past the application directory and a cache directory. Since mostly what you're doing in build packs is downloading things and then installing them, you don't want to be going out and downloading those things from external sources any more than you have to. So what compile scripts can do is when they determine they need to have access to a JRE or a Tomcat or whatever it is, they can check that caching directory and see if that artifact is already there. If it is, just use it. Otherwise, download it and put it in that cache directory. It's completely up to the build pack what it puts in there and how it checks for it, but it gives you a way to cache those things so you're not going out to a public mirror or a public repository and downloading them every single time. And then the third script is release, and this one does actually the least amount of work of all three. All it does is return a YAML formatted hash with these three keys in it, and Cloud Foundry actually only pays attention to one of these three keys. So the DEA is completely stupid. It doesn't know what this application is or how to run it. The build pack, along with downloading all these things and installing them, has to tell the DEA, now here's the start command for this application. And the way that it does that is by writing this one line out to this YAML output that it returns. And it's just a command that DEA is going to run as a shell command to start the application up. Now, if you do care about writing your build packs for compatibility with other platforms, then you need to check with those other platforms and see how they may use these other values. But Cloud Foundry is only going to use this one. The add-ons one in particular is for Heroku, and you can write values into that array that are Heroku add-ons that Heroku will somehow take and add to there as well. Yes?
Is it possible to allow application deployers, the developer side, to pass custom properties for startup of the app?
That's possible, yes, if the build pack wants to do that. Yeah, so the sort of things you could do if you're writing your own build pack is you could define some configuration file format and have that configuration file pushed with the app, and then the build pack could look at that configuration file and make decisions based on that, if that's the sort of thing you decide you wanted to do. When we get into the Java build pack, we'll see how the Java build pack chooses not to do that sort of thing, but you certainly can. Is that a question?
Yeah, Scott. So when I was hacking on build packs a few weeks ago, the thing that I wanted to do was inject something into the path variable. Is there a kosher way to do that? Because the Heroku way is modify it through the config bars, but obviously that's not being picked up. So is there a kosher way to do that?
The way that I've seen that type of thing done in other build packs is they just set that environment variable at the beginning of the command before the command actually runs. So you'll see path equals and then some path statement and then the actual start command after that.
So if you're wanting to inject a lot of stuff, that's going to get ugly really quick.
Yes.
Yeah, okay.
Yeah. Okay. Let's stop there for a second. This is the section on you want to write your own build pack from scratch. Here's what you have to know about how build packs work. The best way to do this actually is to go out to one of those existing build packs and just see what they're doing and read them and maybe even take one and modify it. So let's stop here and see if there's any more questions about writing your own build pack from scratch before we get a little bit more specifically into a build pack. Yes?
The question is just a piece of information for everyone. On the Cloud Foundry blog, we've got a couple of blog posts about build packs, one of them being from IBM about how they collaborated with
Yes, and you'll also see in the next few weeks, I think, probably even in the next week, another partner of ours is releasing another build pack specifically that they've built towards Cloud Foundry. And I can't say anything more about that because I don't know exactly what their big plans are to splash that. But we are seeing now several companies who are building build packs because they want their runtimes to be available specifically on Cloud Foundry, which is pretty exciting for us.
Just got one last question.
Yep.
Do you have any guidance on maintaining build packs along with the evolution of stem cells? Since they are environmentally running on the stem cell, probably some dependencies or some gotchas that you could have there.
Well, my guidance in terms of that is to keep your build pack as simple as possible. And what most build packs do is just download some zip file, like the Ruby interpreter, the Node interpreter, most Python interpreters, they're just zip files that you're downloading and unzipping, and that's really all you need to do. So if you start to get more elaborate than that in build packs, then you're going to be more sensitive to that sort of thing. So keep it simple, download stuff, unzip stuff. Maybe, build pack is free to go in and touch configuration files, but just keep it to that sort of thing and try not to go and manipulate the whole operating system kind of environment.
Another question up there.
Yeah, go ahead, you go first.
So the detect script that prints a string out, how would you get that string, or could you get that string if you're pushing an application? Like if you wanted to see which build pack was detected or detected your application?
Yeah, I'll show you one piece of that in a minute. But the answer is a little bit uneven right now. If you push an application using one of the built-in build packs, then that detect string ends up being written out to a file that you can actually see. That's a part of the droplet that the DEA adds there. So using the cf-files command, you can go look at that file and see what's in it. If you specify the build pack, then the DEA currently doesn't call that detect script, so it can't get that string. It does write to the application metadata in a different field, the URL for that build pack. So right now it's a little uneven whether you let it use a built-in one or whether you specify your own. Different information gets written to different fields in the app metadata, which is something I think we need to adjust a little bit. But I'll show you here in a minute where you can see the output from the detect script if we're using a built-in one. I think it would be better if DEA still called the detect script for one that you specify yourself, just so we can write that same information out and give you a little bit more information there.
Is there any way to instantiate a container based on a build pack outside of the Cloud Foundry environment? So, for example, I want to do testing or development of my application, but I want to use the same environment that's going to be on the Cloud Foundry when I deploy it, but I want that outside of it before.
You want local development environment?
Yeah.
Yep. That's
So
a great question.
Is there any way? Because some of these containers, all this, you can get it outside, but I want it in the same configuration, same setup.
You mean the location where the container gets downloaded from?
No, not necessarily the location, but the exact instance of like when the build pack is instantiated in a container, the same thing with all the same configuration outside of the Cloud Foundry environment.
Yeah, I'm not clear. When you say container, are you talking about like our Warden container or like a Tomcat kind of container? That's where I'm confused.
So the DEA has the Warden container.
Right,
And
yep.
in the container, the build pack will be instantiated when
Right.
you push the application.
Yes.
So is there any way for that to happen outside of it?
There's not a way for that to happen outside of Cloud Foundry.
Yeah.
What I've been sort of playing with, and I hope to write up and have a blog entry on soon, is Cornelia was actually doing some of her testing in a small local Cloud Foundry installation. You should be able to bring up a single VM on a laptop that contains all of Cloud Foundry and runs a real small micro instance of Cloud Foundry. And then you get a lot more control over what's going on. And Cornelia actually already has a blog entry that shows how to stage an app into that small micro instance and then go into DEA and go into Warden and start poking around at the files and everything. So that's a really good way to develop build packs, I think, because it can be difficult when you're writing a build pack and something's not working right. You go to push your app, your build pack gets invoked, The app doesn't start for whatever reason, DEA throws the warden container away, and you can't go look at the file system and see what happened. Using the technique that Cornelia, I guess that's an upcoming blog post, right?
Yeah, yeah. And those techniques are things like there is an ability to actually do what's called WSH, which is a warden shell. So you can actually warden shell into the shell, and you can start mucking around in there. So for example, I've done this a fair bit where I deploy something, it's not working right, I WSH in there, I look at the logs. You can do it all from CF, from the command line, but that's a little bit burdensome because you're uploading and downloading files and looking at those files. And I can go in there and just say, oh, I see what the error was here. Let me change my environmental variable, or let me actually go into my code and make a slight change in the code and see if it works and restart that process inside of the warden container. So you're asking a really great question, which I'll generalize as how do I have a development environment to help me using some of these things, and we will have lots and lots more information and tooling to help you. Offline disconnected, yep. Get it. We'll have more stuff coming.
That's what we're talking about. Yeah, there's a CF Vagrant installer, and then there's the CF Niche
Yep.
installer. So if you use either one of those to get a micro-sized Cloud Foundry deployment in a VM on your laptop, then you can do all sorts of things in there that you can't do on run.pivotal.io. So, yeah.
It does. It works great.
Yeah, those installers work great. The information we need to share, Cornelia's done a lot of work here, and I want to build on that, is now that you've got that, how do you get in there and really get up to your elbows in the DEA code and the warden containers and all that, so you can really see what's going on in there? Let's get to...
There's something called a buildpack cache.
Yes.
And that is different from this app cache that you're talking about.
It's the same thing.
Is it the same?
Yeah. So that second directory that gets passed to the compile script is just a directory on the file system as far as the build pack is concerned, but that's the build pack cache. So anything that the build pack downloads, it can feel free to put into that directory, and that is the build pack cache.
Can I pre-populate that?
No, there's not a way to pre-populate that right now.
I got a question.
Yep.
So, what is it like stuff in the build pack that actually like monitors the health of the app, like if it's flapping or it's crash or stop?
No, that's the DEA doing that purely. So when this start command gets called, the DEA monitors the process ID that comes back from that. And so the DEA needs to know what that PID is, and then the DEA and the health manager will watch that PID and see if that process stays running or not. If that process dies, then that's how the DEA knows that the app is flapping. The DEA also knows whether a URL is bound to that application or not, and it will hit that URL and see if it gets a 404 or something else.
So that's it. That's the only thing you guys check on.
Yes, that's it. And that's a good point. That's something I wanted to mention here that I forgot, so I'm glad you mentioned that. This start command that you put here has to be a long-running process. We have had cases where we've helped people get build packs going, and what they've put into the start command is a script that starts something else in the background, and then that script exits. And the process ID that DEA sees is the process ID for that initial script that started a background thread and exited. So DEA thinks the application died. So this command that you pass here has to be a long-running process, or the DEA will not recognize that that application is running. That's really important. We spent probably a good day debugging that.
Just real quick, so how much control do I have over the runtime versions that are used and the container versions that are used with the build pack?
That depends on the build pack and how it's written. And we're going to get into the Java build pack next, and we'll go into some detail on how you can control that with that Java build pack. If somebody else writes a different Java build pack, they may have some completely different mechanism for how you control that. There's been some desire expressed with people looking at build packs to do what I was saying earlier, which is I want to build a configuration file that I push with my application, and that configuration file is going to say what JRE I want to use, what Tomcat version I want to use, all of that, and I expect the build pack to honor that. We chose not to do that in our Java build pack, and we'll talk about what we chose to do instead. But the real answer is, if you don't like the way ours is doing it, go write your own build pack and do your own thing and invent whatever mechanism you want for it. Okay. Okay, 15 minutes? Really? This is going fast. Okay. So now we're going to talk specifically about the Java build pack that Pivotal has written from scratch and the way it works. And the reason we started ours from scratch is we wanted to support a lot of different things really naturally and really easily in one build pack. So this build pack supports Java, Groovy, Scala, really anything that can be compiled down to the JVM. It knows about Spring apps, it knows about Grails apps, it knows about Play, and it knows about Tomcat. And we'll go into a little bit more about all the things it knows. But the goal with it is you build your application however you want, you push it, this build pack will figure out exactly what it is you're asking it to do and just do it. So there are three concepts contained within the Java build pack, and that's JREs, containers, and frameworks. So you only ever have one JRE, and that's the Java runtime that's going to run your application. And your application can only have one container, which really says how an application is run. So Tomcat's an example of a container. An OSGI container would be an example of a container. And then we have this concept of frameworks, which would be Spring, Play, Grails, things like that. So these are the examples of the things that are built into the Java build pack today. These lists will continue to grow over time as we find more interesting things that we can detect and handle for application developers. But in the container section, you'll see there a line that says Java main. This is just you push a jar file, and in that jar file you have a manifest, and the manifest says here's the main class for my application. We'll detect that, and we'll just call that main class and run it just as a bare jar file. Tomcat will detect that it's a servlet application, that it has a web inf directory, and we'll instantiate Tomcat, download it, install it, and run this within there. The Groovy container is really just detecting that everything that you've pushed is just Groovy files, and we just need to run those using the Groovy interpreter. And we'll get more into what each of these things is, but I just want to give you a flavor of the things they support. So this is that additional detail. Don't take this slide as the specification. This Java build pack is really well documented, and if you go to the GitHub page for this, you'll see the exact specification of what the build pack is doing to detect each of these. I really just wanted to give you a flavor of the sorts of things the build pack looks for to decide what it's going to do. So we talked about Java main. If you have a manifest file and you name the main class, then it just does java-jar and the jar file. That's what this container does. Tomcat looks for a web inf directory. The criteria for Groovy is a little bit more complex because we need to make sure that it's really just a plain Groovy script, more or less, is what you're trying to run. So if there's a Groovy file that has a main, we'll go run that main as a Groovy file. Or if there are no classes, which really means it's a Groovy script, or at least the entry point to your application is a Groovy script, then we'll run that as a Groovy script. Spring Boot CLI is a really, really neat one. You've heard about Spring Boot already in the keynote last night. So what you can do with Spring Boot is write Groovy files that are just your web application controllers, and then just run those with a command line tool. So this Java build pack will detect that, that there are Groovy files, that they have no main method, and that it's not a web inf directory, in which case we'd want to run it in Tomcat. And it'll invoke the Spring Boot command line interpreter and just run those Groovy files. That is really neat. And then you can see what it does for Play. And the last line there is the build pack is going to look to see which of these containers thinks it knows how to run this application. If more than one says it knows how to run it, it's going to give an error because you can only have one container. And if none of them say I know how to run it, then you're going to get an error saying the build pack doesn't know how to run it. Or technically what will happen if we run through all of these containers and none of them say they know how to run it, then the entire build pack is going to return execode 1 out of its detect script. So it won't be a candidate for running this. So these are the frameworks that the build pack currently supports as well. So if we see any Spring core jar file, then we'll know it's a Spring app and we can do some special things with that. Play, if it's a Play application at all, then we know we can invoke some special Play configuration. Same with JPA. And New Relic is a really interesting one, and it's the newest thing that we've added to this build pack. And the thing that's most interesting about it is the build pack looks at the application environment to see if there's a New Relic service bound to the application, and then does special stuff based on that. So most of the detection criteria looks at the application bits to see what's in the application. This one actually looks at the Cloud Foundry environment for the application and makes a decision based on that. And what the New Relic framework does in that case is it goes out and downloads the New Relic agent adds that to the Java run command line, goes and gets the license for this New Relic instance out of the services and adds that to the command line, and this is what enables the zero-touch New Relic configuration. You bind a New Relic service to your application on push, and you get New Relic without doing anything else, and it's because of this build pack support that works. And as we run through this list of frameworks inside the build pack, seeing which ones apply, any of them that we get a hit on get applied to that application.
So what happens once it's detected? I mean, let's say in the case of a Spring.
In the case of Spring, what happens is there's a Spring auto configuration mechanism, which is a jar file that when that jar file is in the class path, it looks to see if there's Spring data beans in your application and will auto wire them up to applications or services that you have bound to your application. So that's getting a little bit into the functionality of Spring auto configuration in Cloud Foundry, but in terms of what this build pack is doing, it's just downloading a jar file and making some tweaks to the Tomcat configuration. And then the rest of the magic is in the Spring auto configuration jar file.
Are you going to talk about auto configuration at all?
No, I hadn't planned about talking
Okay,
about
so let me
auto
just-
configuration.
Somewhat this morning in Java
Yeah.
Spring on Cloud Foundry.
Okay,
Yeah,
so let
and
me
I'd
just
rather-
circle back very quickly in 15 seconds. So remember when I said you don't necessarily need to read things in your application from the environmental variables? There's some of that magic, it's that auto configuration that might just take care of that for you. If you're doing something like Scott just said, if you're using Spring data beans, if it finds those, then it might auto wire those backends in for you.
Yeah. But again, in terms of what this build pack is doing, this build pack isn't making any of that happen other than the fact that it's getting another jar file, adding it to the class path for your application, and making some small tweaks to Tomcat. Everything else that happens is just the Spring auto configuration support. So we can certainly talk more about Spring auto configuration support after this. So you've seen this staging output several times. When you do CF push, this is some of what goes streaming by. I just wanted to kind of connect that output to what we're talking about now. So that very first line you see, downloaded app package, that's the DEA taking the app bits out of the blob store and putting them into the Warden container. All the next set of lines that are in bold are things that the build pack is writing to standard out in the course of its processing. So you'll see it's downloading the OpenJDK, it's downloading the Spring auto reconfiguration jar, which is the thing we were just talking about, and then it's downloading Tomcat, and it actually shows you the directory that is downloading each of those into. And then once the build pack is completely done, then it's back under DEA control, and the DEA is then going to take a zip of everything that just happened to that Warden container and store it away. And once that app's been pushed, it's kind of fun to go in and do this cf files command and actually see what's in that droplet. You can only do this after the application has actually started. And this is just illustrating again what the build pack is doing. This .java, this .lib, and .tomcat directories are directories that the build pack created to put the things that it was downloading and installing. The fact that those things are named that is purely decisions that that build pack made. Cloud Foundry, DEA don't care what those things are called or where they are, as long as they're in this directory. And then the other things are part of the application that the DEA downloaded. And then this is going to help with an earlier question. Another fun thing to do is do the CF files and look at this staging info.yml that's at the top of the directory anytime you do CF files. And this detected build pack string is exactly what was returned from the detect script. So if you specify the build pack on push, that string will actually be empty. If you don't specify a build pack on push and let Cloud Foundry run through them all, whichever one it picks is going to get written out there. And then everything after start command is what the build pack put into that web field of that string that's returned from release. And that's just a little bit of highlighting to see what's in there. So Matt was asking about the path. This is a technique that this build pack uses to set up the Java home and Java ops environment variables before it actually sets up this script to run. So I'd assume you could do a similar thing with path. Okay, we'll try to get through this customization part. So if you want the Java build pack to do something differently than it does today, there are two ways you can do that. One is just to configure by changing configuration files that are a part of the build pack. and the other is to write new Ruby code and add that Ruby code to the build pack to make it do something different. In both of these cases, the way you make those changes is you fork our Java build pack on GitHub, make your changes, commit that back to your own GitHub repository, and then specify that build pack when you push the application. So the forking is the method of customizing for this build pack. So if you just want to do configuration, these are the sort of configuration files that you'd be changing. So let's actually start with the bottom one. So this is a YAML file. Everything in Cloud Foundry is a YAML file. So if you can see that at the bottom, you'll see that it's got a version string in there. So this configuration file is specifying what version of the JRE is going to get downloaded for a Java app. In this case, it's saying version 1.7.0. anything after that. So it's going to take the latest one of any of the 1.7.0 flavors. And then you also have the URL that it's going to go download any of those artifacts from. So the Java build pack takes this repository route, looks for a file called index.yml at the end of that, and then goes and looks for a line in that file that matches the version. And it's going to take the biggest version number that matches that string in there. So if all you wanted to do was use a different version of the JRE, you just go into this one configuration file, change that 1.7.0 string to whatever other version you wanted, as long as it was one of these that was in this list, and that's the version you'd be using. So another interesting example is you want to customize the Tomcat configuration, or the Tomcat distribution, I should say. And this example goes a little bit further, because you'll see these URLs are files.example.com. So if you're going to deploy your own private Cloud Foundry and you want to have your own repository of these tar files that have Tomcat in them, then you would need to change this base URL, and it can just be Apache serving up files via HTTP. There's nothing special about where those files come from. And then you can upload your own versions of Tomcat and set whatever versions you want. For Tomcat specifically, I just learned about this last week, so I thought I'd add that to this presentation as well. It's very common if you're running in Tomcat that you be able to customize bits and pieces of the Tomcat configuration in context XML and server XML. So this build pack, when it downloads and unpacks Tomcat, it then goes and gets these two files and drops them into the Tomcat configuration. So if you wanted to change context XML, server XML to enable Tomcat clustering or something like that, you would just fork the build pack, edit these two files, and then there's no code to actually change to make any of that happen. Okay, and then if you want to extend, then you're in a situation where you're writing new Ruby code, and you're going to be writing new Ruby code that's either a new JRE or a new container or a new framework. So these are actually directories in the Java build pack source code, and if you go to GitHub and look at the repository, you'll see these three directories, and in the container directory you would see tomcat.rb, springboot.rb, groovy.rb, all those things that we talked about. And the interface to one of these components that you would add to the build pack looks very much like the top level build pack API. It's got this additional initialize method, but then you have a detect, compile, and release method. So this is sort of another level underneath the bin compile, bin detect, and bin release. When you get into the Java build pack, it's going to call each of these containers and call a detect, compile, and release script inside of there. So when we talked about the criteria for a container, it's this detect script here that's implementing those rules for what a container would detect. And again, the best way to start with this extension is to go look at one of those containers that's already in the Java build pack, copy the source code, start modifying it away. And Andy's telling me I'm out of time. And then the only other thing you do is you go into this one configuration file and just tell it there's another class that it needs to know about that's another container or another framework or another JRE. And we can go into a lot more detail about this part of the Java build pack after this. Ben Hale's in the back of the room. He actually wrote this. I'm sure he'd be happy to answer questions as well. So he knew I was going to mention him at some point. So we can certainly stick around and answer more questions about it. And the GitHub repository for the Java build pack has a lot of really, really good documentation. Ben and Glenn really spent a lot of time making sure this was really well documented. So go out there and read that if that's something you're interested in doing. And that's it. We'll be up here for a few more minutes to answer questions.